In question 11, they have given us a graph which has the equation y equals e raised to a minus 3x minus 3e raised to negative x. So this is the equation of this graph. Now, the curve C has a turning point P and crosses the x-axis at the point Q as shown on figure 2. Okay, so P is a turning point and Q is where the graph crosses the x-axis, and then this is the point where it crosses the y-axis. Let's see. In part A, we have to find in terms of A the coordinates of the point P. So to find the coordinates of the point P, what we can do is we can find the derivative of the curve C, basically differentiate the equation, and that differential, which we will find, should be equal to 0 at the turning point because dy over dx equals 0 at any turning point. So when it will equal 0, we can find the x coordinate of this point, and we have to find both the coordinates, so we can just substitute that x which we find in this equation y, and we will get the coordinates of P. So let's see how we have done that. So in part A, dy over dx equals negative 3e raised to a minus 3x. So this I've done already, and I've written it in the simplest form. So plus 3e raised to negative x. That's fine. Now at P, dy over dx equals 0, as I mentioned. So this entire term, what we found, will be equal to 0. When we simplify this further, we get negative 3 as a common factor. And when we get that, so we can write it down as negative 3 and then e raised to a minus 3x minus e raised to negative x equals 0. Now this, we can divide both sides by negative 3, so we will be left with e raised to a minus 3x minus e raised to negative x equals 0. And then we just add e raised to negative x on both sides and we get this. Now taking the natural log on both sides, we can cancel the e's that way. So when we do that, we get negative x equals a minus 3x. So 2x equals a, and therefore x equals a over 2. And we have to find the coordinates in terms of a, so that's fine. So this is the x coordinate. Now substitute the x coordinate, which is a over 2, into the equation. So when we do that, this is where I've substituted x, here and here. So after we solve this, we get negative 2 e raised to negative half a. Now in part B, we have to find in terms of a the x coordinate of the point Q. Now to find point Q, what we have to do is simply, we know that at Q, y equals 0 because it crosses the x-axis, so y is 0. So we can say that e raised to a minus 3x minus 3e raised to the negative x equals 0. So we can write that as at Q, y equals 0, and therefore e raised to a minus 3x minus 3e raised to the negative x equal 0. Now e raised to a minus 3x equals 3e raised to the negative x because we add 3e raised to the negative x to both sides. Now, since we have only two terms, we can take the natural log on both sides. So I'm going to write it down as the natural log of e raised to a minus 3x equals the natural log of 3e raised to the negative x. Now for this one, we can just write it down as a minus 3x using the log rules. Now for this one as well, we know the addition rule of the logs, that when two logs in the same base are being added together, we can just write it down as the natural log and multiply the terms inside the logs. I mean, it's basically like this. If you have the natural log of a plus the natural log of b, you can write it down as the natural log of a times b. So here we have 3 times e raised to the negative x, so we can just break it down and write it in this form. So the natural log of 3 plus the natural log of e raised to the negative x. Now a minus 3x equals the natural log of 3, and this will be negative x. Now I'm just gonna bring all the x terms on one side. So a minus the natural log of 3 equals 3x minus x. So we have a minus the natural log of 3 equals 2x, and therefore x equals half. When we divide both sides by 2, so we get half a minus the natural log of 3. So this is the x-coordinate of the point Q in terms of a. So that's done. Now in part C, we have to sketch the curve with equation y equals the mod of e raised to a minus 3x minus 3e raised to the negative x, and show on your graph the exact coordinates in terms of a of the points at which the curve meets or cuts the x-coordinate. Now this is what the graph will look like. I've drawn it. So this line will remain the same, and this will go up. Now this is because we're drawing a mod graph, and whenever we have a function and we draw the graph of the mod of the function, it's always reflected in the x-axis, and whatever is above x-axis remains the same, and whatever is below the x-axis just gets reflected in the x-axis. And we also need to write the coordinates of the points where it crosses the coordinates where it crosses the axes. So here and here, these 2 points we have to find. So Q we already know. Now for this point, we can find it simply. Now for Q, we said that y was 0. Now for this point, let's say that it's R. So at R, x will be 0. So we can substitute x equals 0 into this equation. So that is simple. We can just write it down as when x equals 0, y equals e raised to a minus 3e raised to 0, and therefore y equals e raised to a minus 3. Since e raised to 0 or anything raised to 0 is 1, so 3 times 1 would be just 3, so we have the y-coordinate, and the x-coordinate is obviously 0. So we're just going to write the coordinates here, the exact coordinates. For Q, we have half, and then a minus the natural log of 3, and then the y-coordinate is 0. And for R, we have the x-coordinate, which is 0, and the y-coordinate is e raised to a minus 3. And this is what the graph looks like. Okay.